Good morning, children. Today we will study the measurement of electrode potential. Already you know about the electrode potential. So first we will see what is the meaning of standard electrode potential. Now the potential difference developed between metal electrode and the solution of its ion of unit molarity at 25 degrees Celsius or at 298 Kelvin is called as standard electrode potential. So the definition for the electrode potential. Now we will study the electrode whose potential is called as reference electrode or standard electrode. So this is standard electrode in your course is standard hydrogen electrode. That is also abbreviated as SHE, in which a bigger hydrogen electrode is primary standard electrode. It consists of a small platinum strip coated with platinum black as to absorb hydrogen gas. A platinum wire is welded to the platinum strip and sealed in a glass tube as to make contact with the outer circuit through mercury. The platinum strip and glass tube is surrounded by an outer glass tube which has an inlet for hydrogen gas and at the top and a number of holes at the base for the escape of excess of hydrogen gas. The platinum strip is placed in an acid solution which has H plus ion concentration, that is 1 m or 1 molar solution of acid. Pure hydrogen gas is circulated at 1 atmospheric pressure. Now pure hydrogen gas is circulated at the 1 atmosphere pressure. A part of the gas is adsorbed at the rest and the rest escape through the holes. This gives an equilibrium between absorbed hydrogen and hydrogen ions in the solution. So this hydrogen will be adsorbed and then there is the equilibrium is established between the hydrogen gas and hydrogen ions present in the solution, and which is represented as H2 equilibrium between 2 H positive ion plus 2 electron. The temperature of the cell is maintained at 25 degrees Celsius. By international agreement, the standard hydrogen electrode is assigned a potential of exactly plus minus 0.0 volt. For the calculation, we take the standard potential for the hydrogen electrode is 0 at 298 Kelvin and 1 m concentration, and the pressure of hydrogen gas is 1 atmosphere. The electrode potential for the hydrogen electrode is 0 volt. Now this hydrogen electrode obtain 1 or 2 half cells of the voltage cell. So this reference electrode can be used to determine the measurement of electrode potential. And the hydrogen electrode thus obtained forms 1 of 2 half cells of a voltage cell. When the half cell is connected with any other half cell, a voltage cell is constituted. The hydrogen electrode can act as cathode or as anode with respect to other electrode. Now the standard hydrogen electrode half cell reaction is H2 ionizes to give 2H plus ion with the loss of 2 electron, and that is the oxidation of hydrogen, and its electron potential is 0 volt, and then it will act as anode. Now for a standard 2 hydrogen H plus ion from the solution will gain 2 electron and will convert into hydrogen gas, and again it will work. The electrode potential is equal to 0 and it will work as cathode. So this is called a standard hydrogen electrode, and it is also called reference electrode because its electrode potential is known. The electrode whose electrode potential is known is called as standard electrode. There are so many standard electrode we use, but in your course there is only one, that is standard hydrogen electrode you have to study. Now this hydrogen electrode is used to find out the electrode potential of the other metals. For this purpose, you can see here the hydrogen electrode can work as anode or work as cathode. The metals which are more reactive than hydrogen, then the metal will act as anode and the hydrogen will act as cathode. And the metals which are less reactive than hydrogen, then the metal is having more tendency to reduce, then the hydrogen electrode will act as anode and that metal electrode will act as cathode. So for the measurement of the electrode potential, the measurement of electrode potential of a given electrode is made by constituting a voltaic cell, that is by connecting it with a standard hydrogen electrode through a salt bridge. 1 m solution is used in hydrogen half cell and the temperature is maintained at 25 degrees Celsius. The EMF of the cell is measured either by calibrated potentiometer or by a high resistance voltmeter, that is a bulb voltmeter. The reading of the voltmeter gives the electrode potential of the electrode in question with respect to the hydrogen electrode. The standard electrode potential of a metal may be determined as it is the potential difference in volt developed in a cell consisting of two electrodes. The pure metal in contact with a molar solution of one of its ion and the standard hydrogen electrode. So in brief, I am repeating the electrode potential of an electrode is measured by constituting a voltaic cell in which if a metal is more reactive, you can take the example of zinc. The zinc is more reactive than hydrogen. So zinc will act as anode, then the hydrogen electrode will act as cathode. When you make a voltaic cell, the potential difference between the two can be determined from the voltmeter, and then you know the E0 cathode minus E0 anode is equal to EMF of the cell. So EMF of the cell is measured from voltmeter, and then the cathode you know is 0 volt. Then we can find out the electrode potential of the zinc. For example, the cell potential difference is plus 0.76 volt in case of the zinc. So we can write 0.76 is equal to E0 anode plus 0. So E0 anode is equal to plus 0.76 volt, that is the oxidation potential, and the reduction potential of the zinc is minus 0.76 volt. So similarly, we can find out for the copper electrode also. So when you use the copper electrode, then again you have to construct a voltaic cell in which the hydrogen electrode will act as anode and the copper electrode will act as cathode. And then again you can write here the E0 cell is equal to E0 anode plus E0 cathode. So now for 0.344 volt, 0 plus E0 cathode. So for the reduction potential, E0 cathode will be equal to 0.34 volt. So in this way we can find out the measurement of the standard electrode potential of the different electrode. This is a way to find out the standard electrode potential of the different electrode. And these electrode potentials are represented in the electrochemical series in terms of their reduction potential. So this is the way to determine the electrode potential.